Any doubt? If anyone is having any doubt, please let me know. Otherwise, we should move ahead. Right? No doubt? Yes. At least you people can respond. Na? Yes, any doubt or not? Okay, then fine. So, okay. Semantic analyzer. Okay. Okay. Semantic analyzer part. Mm. So in the last class, I think we have covered till here. We were in this on this slide, right? Or we have moved ahead? No, I thought we were at this slide. Semantic analyzer is basically yes, syntax analyzer checking the syntax part. Okay, we have moved ahead. Okay, Tanya, let me yes, tell me. This slide we have completed. No, I don't think so. Okay, yes, this slide I think we have no. So we have actually this particular course compiler I was teaching in three different sections, right? So that's why, and in online I may we had to start from synthesis phase, intermediate code generation. Okay, I have uploaded the content to your portal, right, of lecture one. Just go through that part and then let me know how much we have discussed, right? So in lesson one, in lecture one, I have uploaded the content of introduction part. You can go through that and then let me know from which slide we have to start, right? Conjunction tools, I think we have discussed. Yes. So after that, we were in slide 16. So this one, na, that I also I was talking. We were on phase of this phase of compiler. Okay. 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 Fine. Fine. Okay. So fine. Uh, so till now we have discussed the basic concepts of compiler. What is the basic definition of compiler, right? So why machine learning, machine learning. So sorry, why machine language or machine level code or machine code is so much difficult to learn because it is depending upon the machine to machine and knowing the address locations. All these are a complex scenario, right? And we have moved ahead with assembly language programming. And in assembly language programming, we have seen over there there are some operation codes involved like MOV for move operation, STA for store operation, ADD for addition, SUB for subtraction, and so on. So we need to remember those operation codes along with it is also depend upon machine to machine as well because it is depending upon the hardware. We are directly referring the register name like R1, R2, R3, etc. in the assembly language programming, right? So and there is also a machine dependent part, right? Now we have moved to high level language, right? And in high level language we discuss the feature of the high level language, what are the contents in high level language. Why, like natural language also is you can say the highest level of language, like natural language, like whatsoever I am talking, the computer, the system should process it, right? Then definitely compiler is required. It will come like say in over the phone I am just speaking, okay, just call Suresh. So what my phone will do is it will find out my contact details. It will search for Suresh. If there are two named Suresh P, Suresh Kumar, so it will ask me which Suresh you want, Suresh P or Suresh Kumar. Then I have to select okay Suresh Kumar. Then it will move ahead and it will connect the call. It will dial that his number and then make a call. Right. So what is the significance of that? Talking here is the natural language is also one of the highest level of language, right? So and through this as well, not at this era, maybe some era will come that we program like this in natural language and computer is able to understand those sort of things, right? So again, if we are making a program in natural language and computer is intending to understand, it means that we need to develop such compiler so that computer is understanding all those sort of things, because computer understand only what? Computer understands only machine language, but computer is understanding my speech, my voice, my it is recognizing the context which I am wanted to say, right? It means the compiler is required, right? So high level language could be anything like C, C++, Java, Python, Perl, right? Or even the language which we are speaking, that may be treated as a highest level of language in coming time or in coming era. That is again possible thing. We can't say that it is an impossible part. No, we are moving ahead in this direction that we are working on, and the system is intelligent system is about to emerge, so that which can recognize the natural language as well, right? So that is the importance of compiler. Right, compiler is very, very important, and we have seen several things about compiler, like compiler history, compiler parts, in which we have discussed about analysis phase, synthesis phase. In analysis phase, I told you the checking the correctness of the sentence or syntax or tokens. All these things is being checked, and if it is valid, if it is okay, then all those things is being passed to the next level, right? And then analysis phase, synthesis phase is come into action, which check which doesn't check the correctness, because the correct sentence has been already received to that level. Right now the transformation or compilation part starts from there, that level itself, right? So that level starts the transformation, and it will transform those high level language into assembly language, and then further assembly language to machine language, right? So that is the basic thing which we have already discussed, and these are some intermediate parts. These are some intermediate positions, like preprocessors are there, compilers are there, assembler are there, linker and loaders are there, right, to help the compiler, right? So these things we have discussed, and these part we have covered, and further we have moved ahead with the phases of compiler. In phases of compiler, we have saw lexical analysis phase, syntax analysis phase, semantic analyzer phase, intermediate code generation, right, code optimization, and target code generator, right? So in say lexical analyzer phase, we have dealt with the lexical analysis phase, right? uh, so again, okay, let me recap something. Like in lexical analysis phase, the string of like in lexical analysis phase, say suppose let's take an example, like int uh, a comma b comma c semicolon, right? So this is a particular syntax, or this is a particular statement of one programming language called C, right? So what it will do is, how it will does this particular statement is passed to the lexical analyzer phase, right? This is my source program, this is being passed to the lexical analyzer phase. In lexical analyzer phase, initially these all things is being divided into token, means all those line is passed at once to the lexical analyzer, and it will divide it into parts. Like what would be the part? So here you can say this is an int, uh, which is your data type in this way, comma, this is identifier named A, comma, this is again identifier named B, right? This is again identifier named C, and then this is say say after this C, right? This is an identifier C. Then after this statement, there is punctuation mark, say punctuation, semicolon, right? Like this. So each token, you can see this is an integer, and this integer is passed as an integer along with its what is that thing. What is the significance of this token? If significance this token integer, suppose it recognize it as a data type, so where from where it will see ki what is this int. So this token is the int. It will go and check into the symbol table and find that this int is a kind of data type, right? So it will say it is an integer kind of data type, so token will return like this. Again further, a a over here is an identifier, is a variable name, so it is an identifier. B is an identifier, C is an identifier, then semicolon is a punctuation sort of thing. So each token is divided into parts like this one, part two, part three, part, right? And then fourth part, yes, and again further comma is also there, like comma is also treated as punctuation, side punctuation, and then it is forward as comma, and like this. So these all commas are also a kind of punctuation, because if comma is missing, it is an error. So punctuation will also should also be there between two identifiers as per rule, so it is there, right? So lexical analyzer will first divide all those one sentence into tokens, each tokens, right? And then each token along with is got associated with its type, what type of token is that, right? And it then the lexical analyzer checks the validity of that token. Suppose int, instead of this int I have written inl, right? So if inl has been passed to lexical analyzer, it will go and check into the symbol table manager. Symbol table doesn't find anything like this, so it will throw an error, it is not being recognized thing. What kind of thing, I don't know, right? So this may be an error, so please resolve this error. The symbol table raise an error handler, right? It generates error message and it will throw an error, right? Suppose yeah, lexical analyzer doesn't throw any error, it means that key all tokens are valid one. All tokens are valid. Like everything is valid. We don't bother ki what that particular token is, and what we don't even bother. Right? Ki what is that? Ki with like say int. int. Suppose I have written like uh, over here int a b comma c. Instead, in between A and B, there is no punctuation mark. There is no comma, right? then who will identify this error? And there is a terminating symbol. So this is again, this is an error because there is an A and B and it is not being identified. So A is identifier over here, right? And B is identifier. In between A and B, there is no any punctuation. So what? So then in syntax analyzer phase, determine the he is having the rule of what? Say like Ram is eating mango. Ram is eating mango and Ram eating mango. Ram eating mango. So it means if it is an eating, so is MIR should be there, right? If it is not there, so that is a correct sentence, sorry, incorrect sentence. Similarly, some rules, some valid rules are there for syntax analyzer as well. And according to the syntax analyzer, rules, because rules should be there, and then on the basis of those rules, it will find an error in this sentence and it will throw the error to the error handler part, and we will get to know, yes, this is an error, right? And how syntax analyzer in background work, how syntax analyzer find those sort of error? So using, definitely, I already told you, there are some rules associated with syntax analyzer, and those rules are in the form of context free grammar. Like in context free grammar, you must have seen, like say a produces the comma d, b comma d means what? And say suppose, and b and d is your identifier. Say b is what? Your identifier. Again, d is also an identifier. Suppose I have written like this, d is also an identifier, right? So d is also an identifier. So in this case, suppose this sort of rules is there. So in between a and between two identifier, there is comma, right? So if such type of rule I have defined as in CFG, then syntax analyzer should get to know, okay, between two identifier there should be comma, or there may be space. That is fine. So if the two identifier is not separated by anything, then there is something wrong, right? If two identifier is separated by just a space, then there are something wrong. It should be comma, because in the grammar rule I have associated these things, right? So in this way, we need to design the grammar rules for syntax analyzer, so that syntax analyzer will get to know, yes, this is the proper syntax, this is the correct syntax, otherwise this is the wrong syntax. If it is wrong syntax, it will generate an error message, or it will alert us, generate an alert signal to the error handler, and error handler will get to know, right? So I hope the with the such exhaustive examples, you are having a little idea, got a little idea how lexical analyzer works, how syntax analyzer works. If any doubt, please let me know up so far. Is it fine for everyone? Right. Definitely, here we are just talking in a very crude and abstract way, because all these things we have to deal with in very exhaustive and expandable way, right? Because these all are individual units only, right? So don't bother how to design these things. All these things we will see very in unique and expensive, expandable way, right? Okay, lexical analyzer is clear, syntax analyzer is clear. I hope there should not be any doubt. Now come to semantic analyzer, right? Now come to semantic part. The one of my favorite example, which is the bread is eating a dog. I think I have used many times with you. The bread is eating a dog. Grammar doesn't recognize this sentence as a incorrect one, because it is following all those grammar rules. Like over here, the bread, its subject is eating, helping verb, and verb, a dog, is an object. So perfectly grammatically, it is perfectly fine, right? But tell me, is it logical one, or does it okay in terms of logic? Can a bread eats a dog? No, bread is neutral thing. Right, non-living thing. How a non-living thing can eating action is associated with some living things, right? Suppose instead of this bread, suppose something other like man eating a dog, that is fine. Okay, it may be right, or some other fox, like fox, tiger, that is all okay, right? It is fine. But if bread is there, then in such scenario, it is not fine. Okay. So now these sort of things, how to handle? There are some logical errors as well, right? So, and again, all those logical errors cannot be handled by compiler, because suppose as a programmer, I am making mistakes which is neither kind of syntactic nor kind of nor kind of lexical analytical error, right? Which is semantic error, that is fine. So semantic error can be performed like many times we used to say. Now come to the technical example of this semantic analyzer, right? So mm, maybe possible, sometimes I used to say like that is equal to b division c, right? So what happens if c is, and over here if suppose I c is your what, 0, what you will get? So if we are performing any division operation, there is no syntactical error, right? Syntactically it is, these all are perfect. But semantic analyzer will check, okay, this is the division procedure. So with division procedure, if it is 0, if c is 0, then there is a chance that it may get infinity, right? So it means that the division, anything cannot be divided by 0, right? So it is a mathematical exception. So if the semantic analyzer will check whether the programmer is handling those exceptions. If it is handled, then that is fine. There is no problem. If programmer doesn't handle it, then it may tell you the warning. Might be some case semantic analyzer may produce some warning error code or some sort of error message, right? So that is depending upon the severity of logical error which the programmer is performing, right? So this is the one of the technical example, and this is the bread is eating the dog. This is the hypothetical example, you can say, right? So I hope semantic analyzer is clear to all. What sort of yes, so programmer is a semantic analyzer. So programmer is a, no. Semantic analyzer is a part of compiler, right? Programmer is a user, right? Programmer is user. Programmer, like while writing, I don't bother about the bread is eating a dog. That is the overhead of under listener. Whether how listener is interpreting these things, speaker doesn't matter, right? So the like this over here, it is an overhead for programmer as well as semantic analyzer. Maybe yes sir, I read that it also checks whether a variable has been declared or not, but is not declaring a syntactical mistake. Yes, like definitely, like say suppose integer I have used, I haven't declared it and I'm using it. So it may produce some error, and it doesn't, it is not a semantic error. In fact, it is a syntax analyzer's error. because syntax sees that okay, like say, just take an example, int int a comma b and colon, right? And in the next line I'm using uh, b is equal to a plus c, right? So some compiler allow this, but some compiler may doesn't allow this. If some compiler doesn't allow this, it means that their syntax analyzer, will work like that. It is like syntax analyzer sense these things and sense that no, C is not a valid identifier because C has not been declared yet. So it should throw an error, or some compiler, right, may allow this key, and with the wording that you haven't declared C, C may have garbage value and you may have garbage value in B, or in undefined value you may occur, right? And practically, like listen, like it is the theoretical concept that the compiler has been divided into these sort of phases, right? But in order to develop a compiler, right, it might be possible that these two phases may club together, right? During implementation part, these two phases may club together and find a single unit. Yes, that may be a case, and that may also be there, right? So the question is, so programmer is a semantic analyzer? So no, programmer is not a semantic analyzer. Programmer, I think this should be clear, Aryan. And then Uddhav, sir, I read that it also checks whether a variable has been declared or not, but is not declaring a syntactical mistake. I think I have also answered these things as well, because yes, it may be possible that if you haven't declared any variable, then it won't throw any error, or it may come with warning as well, or even not even anything. That is fine. That may be there. So depending upon the compiler to compiler, if compiler gives the flexibility to the programmer that at least these sort of things you can do by your own, then definitely. So that depends upon programming language and its compiler, right? Okay, it is not a hard bounded thing that without declaring any variable you can't use this, right? But definitely in C programming it is there, in C++ it is there, in Java it is there, but in Python nothing, you need not to declare it, right? So it is not like that before declaration, before using that variable you need to declare only. No, it's not always true, right? But definitely that is uh, depending upon the particular language, how the language is allow, whether the language is allowing such things or not, or what is the basically core of those language, or what is the core of those concept of that language, right? So compiler is written on that way and in this view. Okay, fine. So I hope till semantic analyzer we have made clear to all of you, right? Okay, fine. Yes. So now come to intermediate code generator. Fine. So intermediate code generation part, till here what we have observed or what we have seen, that all these parts is being used to analyze the correctness of the language or of the code. Till so far we haven't did anything to convert the given language into, or we have not proceeded towards uh, conversion part. We have we were in on the checking mode only, analyzing mode only, whatsoever is written, that is correct one or not. If not, then throw an error. And if not so much reluctant, then throw a warning, or etc etc, right? So till there, we this is called analyzer. And now from here onward it is called synthesizer, means it is converting the things. Right, now how intermediate code works, let's come and discuss. uh, so now let me talk about intermediate code. Say a is equal to b plus c. This is a particular statement, right? I have written. So what does it do, right? What does it do? Intermediate code. How an intermediate code can be generated? So intermediate code is a code before you can say machine level or assembly language, right? It is just another abstract level of coding, like whatsoever programmer wanted to do, right? It is basically an intermediate between uh, that program and compiler, right? Because compiler understands computer understands only assembly language or machine language, right? So it is in between of assembly language and the high level language, right? Say suppose a is equal to b plus c, right? So suppose there are multiple ways of writing an intermediate code or generating an intermediate code, right? Like there is a concept of three address code representation, right? There is an another concept, two address code representation, two two address code representation. So there are again multiple ways to represent intermediate code, right? So two address, three address, these are the some ways to represent. Okay, so what is two address, three address, all these things we will discuss much more in detailed way in the respective part, right? Just but still here only I'm just giving you a brief idea how this it is work, it works, right? So like a is equal to b plus c. So three address code states that maximum three address locations can be referred at a time, right? And I'm just letting you know there is no any operation or there is no any instruction exists which need more than three address locations, right? ऐसा कोई इंस्ट्रक्शन एग्जिस्ट नहीं करता है जिसको तीन से ज्यादा एड्रेस लोकेशन की जरूरत हो, क्योंकि थ्री एड्रेस रिप्रेजेंटेशन से हम किसी भी तरह के इंस्ट्रक्शन को रिप्रेजेंट कर सकते हैं। जैसे यहाँ पे तो ए इजकल टू बी प्लस सी, इसको कहो तो ये अपने आप में ही थ्री एड्रेस लोकेशन ही है, तो ठीक है, दैट इज अगेन ऑटोमेटिकली इट इज इन थ्री एड्रेस कोड। से सपोज अगर ऐसा कुछ है ए इज इक्वल टू बी प्लस सी मल्टीप्लीकेशन, डी डिवीजन, एफ माइनस जी, and then raised to the power. Suppose this is the scenario or this is the statement, right? Now there are multiple variables like a, b, c, d, f, g, h, right? So 3, 4, 5, 6, 7. There are total 7 variables involved. But again, this also can be converted into at max. Might be there is no single like. Okay, let me complete it first. Let me convert it into three address code, right? So C into D. ठीक है, we are not learning alphabet, right? So if E missed, don't worry. Okay, so A B C D F G H, these are variable name only. I hope it is fine. Okay, so the thing is you can see the this exponential function is having highest priority, right? this exponential function is having a highest priority, and this there is an f minus g. F minus g is there, so f minus g I can write like there is a variable, temporary variable, say t1. Yes, t1. Okay, let me use temp1, which is your temporary variable, temp1 f minus g. Okay, is it fine? The first is okay. Temp is equal to f minus g. Now temp2 is equal to temp1 raised to the power h. Is that okay? Can we write like this? So this all becomes temp2. Now temp3 is equal to c into p. Now it is your temp3. Now temp4 equal to, this whole becomes temp f minus g raised to the power h is temp2, right? And this is your temp3. So temp3 upon temp2. So temp3 division temp2, right? So this becomes your temp4 is that much. What is temp4? Temp4 becomes that much, right? So this part your temp4 is what? Temp3, which is c minus d, is temp3, and then upon temp2 is this, right? And then temp5. Temp5 is equal to b plus temp4, right? So this becomes your b plus temp4. So this whole becomes what? This whole becomes your temp5. Now what? That temp5 need to assign into a. So a is equal to temp5, because three address code states that maximum three address locations should be there. So maximum, each code involves maximum three address locations. So yes, it is there. It has been converted, right? So this is a very crude example of conversion of like now this becomes your intermediate representation, because if we are able to do that, then you can see like uh, like you have seen that a is equal to b plus 2 or b plus c. How we have made conversion, uh, converted this syntax into assembly language, all of us know, right? Move b, कैसे हमने किया था इसको? move b comma r1 लिखा था. Then further uh, add c comma r1. The r1 is getting c is getting added to r1, right? And then further move uh, r1, the content of r1 should be moved into a, right? So it becomes b, content of b has been stored into r1, content of c has been added with r1, and then the content of r1 is added to in moved to a. So in this way we are able to make complete, right? So in this way we are able to do this, right? So the thing is here, this, and you can compare these are the things. Then instead of this plus there is division, so instead of this add we can apply division, multiply, right? So all this statement is being represented only addition, multiplication, division only, right? So all those statements which involves these sort of things can be converted into this way and represented it into, and in, all those statements involved in our programming can be converted into intermediate code, and then further intermediate code can be easily converted into assembly language. I hope this is clear to everyone. Please let me know if you are having any doubt up so far. Is that okay? Yes, please let me know. Sir, is all this done using stack? Don't use that word right now, like in postfix evaluation and all. uh, no, अभी हम लोग stack वगैरह की कोई बात नहीं करेंगे. Don't put all those big terms as of now, right? So अभी जितना मैंने बोला बस यही हो रहा है, इससे ज्यादा कुछ नहीं हो रहा है. There is no stack, nothing else. Don't bother about that as of now. We don't need that. Whenever it's required, I will let you know and I will explain each and everything. Don't worry. Right? Okay. Anything else? Yes, please. Yes, any other question? Anyone can ask? Is it fine? Shall we move ahead? Okay, fine. So, okay, fine. Okay, fine. So, after intermediate code, next the code optimizer. Fine. So, before conversing, after getting the intermediate code, the next is code optimization, right? So let me explain this with another example, right? Say, suppose a statement involves a equal to b plus c division f plus mm, b into b plus c, right? So what we will do during intermediate code, I'm again coming into intermediate code part, because you should know what is the why intermediate code is not optimized. Then only again you will get to know why optimizer needed, right? Like suppose this is an statement, right? So in intermediate code, what we used to do is we take temp1 b plus c. Temp1 equals to b plus c, right? Then again temp2 equal to temp1 division f. Then again further, now here, since this is b plus c, again this is b plus c, but we are not using temp1 again and again. Variable temp1 cannot be used. Are you getting my point? For this b plus c, another variable, say temp3, will be using, because at that moment of time compiler doesn't know what is that. It recognize each step and it will do like this. So temp, then again it will do like b plus c as a temp3, then temp4 e into temp4, right? Now sorry, temp3, and then this all becomes, what? Temp4, and these all becomes temp2. Now temp5 is what? Temp5 is equal to temp2 plus temp4, right? Temp2, which is this one, and temp4, which is this one, and this. So, so in this way, we are doing. Is it fine? So this is again an intermediate code for this instruction, right? So and then I hope you must get it why the optimization is required, because since b plus c and over here is again it is b plus c, so why we need two different variable, right? So this temp3 and temp1 should be equal, then we can only use temp1 only and then we can go ahead, right? So in this way we perform optimization, and there are some mechanism to get the to perform the optimization, right, which we will be dealing during the optimization only, right, because that part is not this sort of mathematics that involves tree structure, right? So we will discuss it whenever it required, right? So I hope the optimization is clear and need of optimization is clear. How to perform optimization still I as I haven't discussed. So why, what is the need of optimization? I hope this would be clear to all of you, right? Is it fine for everyone? Intermediate code part and then optimization is clear, and then final code generation or target code generation, like if we are able to perform these things, and then we are able to perform optimization of this intermediate code, and then I already told you with this intermediate code, the like this each statement is being performed or is being converted into target code, as we have discussed in the assembly language or in assembly programming, right? So target, it is very easy to get the target code of those intermediate coded language or those intermediate coded optimized language, right? Is it fine for everyone? Again yeah, I kept these two part as an abstract. Still now it is not very much clear to you all that what we are doing this, what we will be doing inside this part, right? And generally like these two phases I told you, in some programming language they may come all together. So similarly this code optimization part and code generation part may come all together. During generation we are used to optimize the things, right? So all together we will finally generate the target code. Is it fine? Sir, can you say again what's the need for code optimization? Okay, code optimization, here the need is as you can see here, we have used in intermediate code generation, we have used temp1 and temp3, two multiple variables for the same operation b plus c, b plus c operation is adding of b and c, and here we have used two different variables, right? So does this code is optimized? So no. Then how to optimize it? We may optimize it with the help of this only one variable, like since b plus c is both operations, so b plus c is temp1, so again over here we use temp1, and again over here we use temp1, and then we will get the answer, right? So without using another variable we can optimize it, right? So that is the requirement of optimization. Clear? Okay, any other question? Yes, please ask. No? Fine. Okay. Then moving ahead. Now lexical analyzer part. Lexical analyzer. How this lexical analyzer works? It reads the source program character by character. As I told you, lexical analyzer, what lexical analyzer do is say it is an int a comma b comma c and semicolon. So it reads the source program character by character. Means int one by one character it will scan and it will take as an input, and the input is int because after that there is an space. So then a is a different token, then comma is again one token, then space breaking it, and then b is one token, comma is another token, c is another token, semicolon is another token, right? So it will read one by one and it will recognize all these things, right? So return the token, yes, it read character one by one and it return the tokens of the source program. Means what? It returned int is one token, a is another token, comma comma is another token, then b is another token, after that there is another comma is another token, c is another token, and then semicolon is another token. So in this small example there are 1 2 3 4 5 6 7 tokens are there. 7 is what? First is uh, int int, another one is a, another one is comma, another one is b, another one is comma, another one is c, another one is semicolon, right? So you can see the token 1, token 2, token 3, token 4, token 5, token 6, token 7, right? So these all are 7 tokens. Okay, so in this way lexical analyzer work. It returned a token. A token is what? Hmm, a token, a pattern of character having same meaning in the source program. एग्जाम्पल एक टोकन क्या क्या हो सकता है? एक आइडेंटिफायर हो सकता है, ऑपरेटर हो सकता है, कोई कीवर्ड हो सकता है, कोई नंबर हो सकता है, डेलीमीटर हो सकता है, एक्सेट्रा. डेलीमीटर वही जो पंक्चुएशन मैंने बोला, लाइक कॉमा, स्पेस, these all are delimiters, right? Operand, operator is what? You can say plus, minus, addition, इस तरह का कुछ हो सकता है. आइडेंटिफायर, ये जैसे न्यू वैल्यू, ओल्ड वैल, these are identifiers, that is your variable name. कीवर्ड्स हो सकता है जैसे कि मैंने int स्पेस इस तरह से लिखा, तो those are keywords. तो इस तरह का कोई भी प्रॉपर्टी हो सकता है हमारा उस टोकन. टोकन क्या क्या हो सकता है? तो ये सारी चीजें हो सकती है. और अब इन्हीं चीजों को वो आइडेंटिफाई करेगा लेक्सिकल एनालाइजर कि वो कैसे वर्क कर रहा है. लाइक जैसे अब एक एक मैं एग्जांपल से मतलब एक तुम्हारे माइंड में थोड़ा स्पार्क लगा देता हूं ताकि तुम उसको सोचना कि कैसे ये रिकॉग्नाइज कर रहा है, राइट? से आइडेंटिफाई कीवर्ड या फिर आइडेंटिफायर. अब मैं ये बताना चाह रहा हूँ कि इसमें कहाँ पर ऑटोमेटा यूज हो रहा है. लाइक इनिशियल स्टेट, अगर ये कहता है कि जो मेरा सिंटेक्स है, जो भी मेरा टोकन है वो कीवर्ड है, तो कीवर्ड वो प्रॉपर है या नहीं है? जैसे एफ ओ आर, सॉरी सॉरी सॉरी, एफ ओ आर, ये इसी को मैंने फाइनल भी बना दिया. चलो ये फाइनल नहीं है. या फिर इसको मैं कर देता हूँ इफ आई एफ. इफ ये जो एक है, इफ इज ए कीवर्ड, इनिशियली यहाँ से स्टार्ट हुआ, इफ फाइनल तक पहुंच गया तो कहेगा ये इट इज ए वैलिड कीवर्ड. से फॉर एफ O R. Then again for becomes valid, right? अगर instead of for की जगह पर मैंने लिख दिया FOG fog by mistake मैंने लिख दिया, तो एक डेड स्टेट होता है, डमी स्टेट, जैसा कि तुमने पढ़ा होगा डीएफए में, दिस इज योर डमी स्टेट FOG, राइट? सो इट वोंट गेट एक्सेप्टेड, ये एक्सेप्ट नहीं होगा, क्यों? क्योंकि ये डमी में आ गया, इट विल नेवर गेट एक्सेप्टेड, तो ये बता देगा दिस इज एन एरर. So internally, lexical analyzer works on the basis of this DFA. तो प्रोग्राम में जो भी टोकन्स है वो वैलिड है नहीं है, that is being recognized by the help of finite automata. Is it fine for everyone? With this notes and takeaway, I'm just closing today's session, right? Is it fine, everyone? Okay, fine. So think about that and then try to analyze the things which I have discussed with you all. Okay, so fine. So with this note, I'm just leaving the session. Okay, fine. So thank you. Okay, fine. So I'm leaving it. Okay.